Okay, welcome back for the last of the parametric equations with trig identities. So I'm just going to look at questions 10 and 11 for this video. So this one has got something in terms of tan squared and something in terms of sine. You've got to try and think, well, how are these two related? Again, think about your identities, think about what you could do to work between the two. And one thing comes to mind, which is that tan squared can be turned into cot squared, so that's a possibility, and sine t can be turned into cosec t. And so there is an identity that links those two, which is this one. So 1 plus cot squared t is cosec squared t. So that's the identity that I'm going to have in mind for this one. If we start with x and think about how to rearrange that, well, I can have x minus 5 is tan squared, and therefore I can get cot squared by flipping that upside down or reciprocating it. So cot squared is going to be 1 over x minus 5. So that's going to be something useful. Let's look at y equals 5 sine t. So I can get sine t on its own, by doing y over 5, and therefore cosec t is 5 over y. Actually, but what I want is cosec squared, so I'm going to square both sides. Sorry about this screen. Cosec squared then is 25 over y squared, so that's what I want for the identity. So coming back to the identity, which is 1 plus cot squared t, giving us cosec squared t. If I put all that together, I'm going to have 1 plus 1 over x minus 5 is 25 over y squared. So this is Cartesian now, but remember in the question it wants us to write it in the form y squared equals f of x. So I want y squared on its own. It's unusual, usually it's y. In this case it's happy for us to leave it as y squared, so that's good. Let's think about how we can rearrange this. On the left hand side I've got two bits that I can add together, and what I could do is make a common denominator of x minus 5, so I'd need to multiply the 1 by x minus 5, and then I've got something a bit like this. I end up then with x minus 4 over x minus 5, and then what I could do is I could bring y squared on its own by multiplying through by y squared, multiplying through by x minus 5, and dividing both sides by x minus 4. So I can end up with that, and if we have a look, well, we could leave it like that. Just out of curiosity, in the answers in the book it looks slightly different, so I'll show you how you can get to that. We can change this into x minus 4 minus 1, which is x minus 5 obviously, and then that can finally turn into 1 minus 1 over x minus 4, which is how it's written in the back of the book. So there's our Cartesian equation. That's what they wanted. It's probably fine to leave it like this. That's exactly how they want it, but in the book they've written it slightly differently. So coming over to part B, it says determine the possible values of x and y in the given domain of t. So this is the given domain of t. So as t ranges between 0 and pi over 2, let's have a think about what happens to x and y. Again, x is in terms of tan squared t. We can consider what happens for tan t. So let's pretend that we've got something else, z equals tan t. And think about what the graph of that looks like. Between 0 and pi by 2, at pi by 2 we actually have an asymptote. So between 0 and pi by 2 we actually have tan t being greater than 0. So think about what happens then to x. Well, x is tan squared t plus 5. If tan t has got to be greater than 0, then so is tan squared t, and adding 5 to that means that x could be anything bigger than 5. So those are the values for x in the given domain of t. Consider what happens to y. So y is 5 sine t. Again, think about what that graph looks like. For sine, it goes up like this, and then at the point pi by 2 it reaches its peak, which in this case is 5. So again, could be anywhere between 0 and 5. So y is between 0 and 5. Okay, so that's question 10. Right, last one, question 11. It looks a bit strange, maybe because we think, well, how is tan and sine related? Well, there's kind of only one thing that we think of with tan and sine, and that's tan is sine over cos, but then that brings in a cos. Okay, well, where does the cos come from? Well, let's have a play around and see what happens with some of the bits. So we've got y equals 3 sine t minus pi, and we saw from the addition formula earlier that we can expand this as sine t cos pi minus cos t sine pi. We know that cos pi is minus 1 and sine of pi is 0. So that's going to really simplify this. So we're going to get cos pi, which is minus 1, so that's minus sine t, and sine pi is 0, so that's just going to be minus 0. So y just becomes minus 3 sine t. That's quite nice. It's quite simple, isn't it? It's a lot simplified. Right, so we'll come over to the x now, and x is tan t. Remember, we think about how we can relate the two of those. So x is just sine t over cos t. Okay, so what we want to do is try and eliminate anything in t. So we can eliminate the sine t's, but we can't yet eliminate the cos t. So I'll start piecing this together and say, well, x is equal to sine t, so sine t then is minus y over 3, isn't it? So minus y over 3 on top, and then we need to find out what cos t is. Okay, so let's then say cos squared is 1 minus sine squared. And we've got something for sine squared now, so that's going to be 1 minus y over 3 squared, which is going to be 1 minus y squared over 9. That's cos squared, so cos t is going to be the square root of that. And maybe asking, is that plus or minus? It's just going to be plus, because cos t in this domain is positive. So it's the positive root. So that's what's going to go over here now on the bottom. And there we go. So that is pretty much Cartesian, but looks pretty horrendous at the minute. We can tidy it up a little bit and say that, well, this is basically that times that, so it might help to rewrite it like this. And if I rewrite it like that, I've got minus y on top, and then I've got 3 times this root. And what I'm going to do is be a bit sneaky and write the 3 as root 9. And doing that means I can combine these two roots, which means inside the root now I multiply everything by 9, and I'll end up with that. That's all equal to x. So that looks a lot better. Can't really do much more with it, so we're not going to. And this is the answer that they get in the textbook as well. So we're going to leave it as it is. We should. I mean, that is the Cartesian equation, but it's worth probably looking at what the x and y values do, so the domain and the range. So over here I'm just going to consider that and just say, well, what happens between when t goes between 0 and pi by 2? X is tan t, and the graph of tan between 0 and pi over 2 looks like this, and therefore we can quite easily say that x is just greater than 0. Not including 0 though, because t is not included the value of 0, so we're not including x, the value of 0. Y is minus 3 sine t. It's much easier for us to take that version, and if we sketch that, it looks like this. So that's minus sine t and goes down to minus 3 at pi by 2. So we simply take the values between 3 and 0. Okay, so that's question 11, and that's as far as I'm going to go with the parametric stuff. Okay.